Hello and welcome! Working with sorted lists can be a bit tricky sometimes. You need to keep the list sorted after each insertion and you need to search for elements in the list efficiently. Binary search is a great algorithm for searching in a sorted list. Implementing it from scratch not hard, but it can be a bit time-consuming. And to make your life easier, Python provides the Bisect module, which makes working with sorted lists a breeze. But let's start from the beginning. What is the binary search? Binary search is a search algorithm that finds the position of a target value within a sorted list. How does it work? Well, imagine you search for a name in a phone book. You don't usually start from the first page and go through each page until you find the name, right? Usually you start from the middle of the phone book and then check if the name you are looking for is alphabetically greater or less than the name in the middle of the book. If it's greater, you go to the middle of the second half of the phone book, and if it is less, you go to the middle of the first half of the phone book. And so on until you find the name you are looking for. So binary search is pretty similar to this. It starts by creating two pointers, one at the beginning of the list and the other at the end of the list. Then, in the while loop, it calculates the middle element of the list and checks if the target is equal, greater or less than the middle element. If the target is equal, it returns the index of the middle element. If the target is greater than the middle element, it sets the left pointer to the middle plus 1 and loops again. If the target is less than middle, it sets the right pointer to the middle minus 1 and loops again. And it keeps doing this until it finds the target or until pointers meet each other, to be more precise, until the left pointer is greater than the right pointer. Sounds like a lot of code, right? Well, kinda, but what if I told you that you can do all of this with just one line of code? Yes, you heard it right, just one line of code. All thanks to the Bisect module in Python. This module is a part of the Python standard library. It provides support for maintaining a list in sorted order without having to sort the list after each insertion. This module uses a basic bisection algorithm to do its work. The Bisect module provides two main functions: bisect and insort. Bisect is used to find the index where an element should be inserted to keep the list sorted, and insort is used to insert an element into a sorted list, keeping it sorted. Now let's try using the Bisect module in practice. First we need to import Bisect, and now let's create a sorted list of numbers. And now we need to insert a new number into the list while keeping it sorted. Without Bisect module, you would have to sort the list after each insertion. For example, data append 6 and data sort, and print the list. This approach can be inefficient and time-consuming. Also, you can find the insertion point using Bisect module and insert method. Bisect left. Here we need to pass our list, and next we need to pass the number we want to insert. And then in the insert method we need to specify the number we want to insert. This will return the index where the number 6 should be inserted in the list to keep it sorted. But for this task, better to use the insort method from the Bisect module. Insort is like insert, but with the difference that it keeps the list sorted. So all we have to do now is type bisect, insort, left, and pass data, and the number we want to insert. In the output we can see that the list is sorted and number 6 is inserted between 5 and 7, keeping the list sorted. And now let's take a look under the hood of the Bisect module. Let's take a look at the bisect left function. Well, bisect method basically just the same binary search algorithm, just wrapped in a function. Bisect takes two arguments, the list A and the element we want to insert, the target value, x. Also, there are more optional arguments like low and high, which are used to specify the range of the list where the target should be inserted. I'll leave a link to the documentation in the description, where you can find more information about the Bisect module. Insort method is used to insert an element into a sorted list, keeping it sorted. So let's take a look at the code of the insort method. The insort method is just a wrapper around the bisect method. It just finds the index where the element should be inserted using the bisect left method, and then inserts the element at that index using the insert method. But insort works like that only if you do not pass the key function to it. Also, there are right variants of this method: bisect right and insort right, which return the rightmost index where the element should be inserted if the element is already in the list. In other words, bisect right will return the index of the first element that is greater than the target, only if the target is in the list. Otherwise, it'll return the index where the target should be inserted. Same applies to the insort right method. It'll insert the element at the rightmost index where the element should be inserted if the element is already in the list. And one more thing to remember: when using bisect on a list of numbers or strings, there is no difference between bisect left and bisect right, because the list is sorted in the ascending order in the case of numbers and in lexicographical order in case of strings, so no matter where the element will be inserted, left or right. But with complex objects, bisect left and bisect right can return different results. Keep that in mind. Let's consider a more complex and interesting example. Let's try to find the word in a sorted list of words. For example, the word guitar in this list of words. Now let's run the code. Well, pretty clean and simple, right? Also, you can find the group of words that starts with a certain prefix with bisect module. Let me copy another dictionary. And let's try to find the group of words that starts with gen. We found the first word that starts with gen, and then you can iterate over the list starting from the index that was returned by the bisect method and check if the word starts with a prefix or not. But note that bisect left method returns the index where the target should be inserted. Bisect left method doesn't check if the target is in the list or not. So if you try to find, for example, the word destiny in the same list of words, destiny, we have only density here. The code will return the index where the word destiny should be inserted, which is 4. But the word destiny is not in the list, remember that. Let's try another example, the binary search problem from LeetCode. Given an array of integers nums, which is sorted in the ascending order, and a given integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. Basically, we need to find index, bisect left, nums, target, and then return index if index not equals to length of list and element at the index is equals to target, else we'll return -1. Now we need to create a list and type print search, pass the list there and add the target. As you can see, the code is much cleaner and easier to understand with the bisect module. Now let's run the code and see if it works. It works. So next time you need to work with these sorted lists, remember the bisect module and save yourself some time and effort.